So this section we're going to talk about how we can go from structural formulas to names and vice versa for alcohols. So for naming alcohols, whenever we have C1 through C4, so that means OH groups attached to a carbon chain that contains 1 to 4 carbons, the first rule is that all of the carbon atoms are going to act as the single alkyl group. So if it's 1 carbon, it's a methyl group, 2 carbons, ethyl, and so on, just like we've seen when we talk about substituents. Then what we do is we add the word alcohol to the ending, as usually it's written as a separate word. So here we have the OH group with 1 carbon. That 1 carbon we consider the methyl, so methyl alcohol. Here we have a 2 carbon chain, which is the ethyl attached to the OH, so ethyl alcohol. Then we've got 3 carbons attached to OH, propyl alcohol. Here the 3 carbons have the OH attached to the middle. So just like when we had the isopropyl groups back with alkanes, now this is an isopropyl alcohol. Here's an example where we've got 4 carbons and it's in a ring, so that would be cyclobutyl alcohol. Whenever we have larger structures, we're going to need to follow our IUPAC naming rules, which connect back to what we were doing with our hydrocarbons. So again, we're going to name the longest carbon chain. The chain name is going to be ending in OL. So with alkanes, it ended in ANE, alkenes, ENE, alkynes, YNE. Here it's going to end in OL. So for example, instead of pentane, it would be pentanol. Whenever you number your chain, you're going to give the hydroxyl group the lowest number possible. So much like we did with alkenes and alkynes, we want to give the OH group the smallest number. That number will be in the name to show you where the alcohol group is. And then you'll go in and put any other substituents in, just like we did before. Whenever you have an OH group that is attached to a ring, the ring is going to number starting at the OH group. So the OH gets number 1. Then you go around the ring to give whatever the next substituent is the lowest number possible, just like we do with any other cyclo group. When you name it, number 1 is not included because we know that it is always going to be on number 1. And then the hydroxyl group, if we treat it as a substituent, we would call it a hydroxy group. Whenever we have more than one alcohol group in our structure, we do much like we did with dienes, trienes. In this case, we're going to have diols, triols. So diol meaning 2, triol meaning 3. In this case, you are going to leave the E in the base name just so that it pronunciation is correct. So instead of ethanediol, it'd be ethane diol, propane diol, and so on. For numbering, you'll indicate the numbers of each location for each alcohol. If you also have double or triple bonds, then we have to have kind of both endings in the name. So here you're going to number your longest chain based on where the alcohol is. So your alcohol has precedence over a double or triple bond, meaning numbering, pay attention to the alcohol, not the double or triple bond. Then the ending, you're going to have, in this case, ENE or EN for the double bonds. Location is 4. And then OL for the alcohol, and its location is 3. So the way this molecule is numbered, we're going to start on the right. The alcohol ends up on number 3. The double bond starts on number 4. Your methyl group is on number 2. We also have trans. Remember, with double bonds, we have to think about cis and trans. So this name has a lot of different pieces in it, but each of them we've talked about individually. Back to our common names that we had earlier. Here's another example. So we've got 4 carbons, but they are not connected in a straight chain. So which of these would be considered common names for this structure? So isopropyl methyl alcohol, isopropyl methanol, isobutyl alcohol, 2-methyl 1-propanol, isopropyl methyl alcohol, and so on. So for the common names, you might not know too quickly which one is the correct one, but the IUPAC, we have very set rules. So let's think about which one of those fits. So for set rules, we don't use the isopropyl. We can get rid of those. 2-methyl 1-propanol versus 2-methyl 1-propanol. Both of those could potentially be correct. They're the same thing. So let's see what's up with the common name. Isobutyl alcohol, isopropyl methyl alcohol. This is an isobutyl group. If you need to refer back to the section where we had those common names. So this answer is B. What's the IUPAC name for this alcohol? So here we have multiple alcohols. We've got 3. So that will have to be a triol. The only option that has triol in it is C. So that must be the answer. They are on 1, 2, and 3. Doesn't matter which direction you name it or number it. 3 carbons is propane. So that all fits. Here are some examples to try on your own. So go ahead and pause the video and see if you can name these alcohols using the IUPAC rules. All right, this first example, we can number our longest chain. Let's try both directions. Remember, the alcohol is what we want to give the lowest number. So my red numbers give the alcohol number 4. My blue gives it number 2. So we're going to go with the blue numbers. We have a methyl group on number 3. So we've got 3-methyl. Need to say where the alcohol is. It's on number 2. 5 carbons is pent. Everything is a single bond, so we're going to have the A in there. We drop the E and put on OL. So 3-methyl 2-pentanol. The second example, it doesn't matter which direction we number it. Both directions are going to give us alcohols on 2 and 3. So we're going to have 2, 3, 4 carbons is bute. Again, all single bonds, so butane, drop the E. And then we've got 2 alcohols, so it'll be a diol. So 2, 3, butane. Actually, we do have the E in there because it's the di, so butane diol. This next example, we have a ring, and we have a double bond, and the alcohol group. So the alcohol group gets precedence, so it's going to be number 1. If I number clockwise, it puts the double bond on number 2. If I number counterclockwise, it puts the double bond on number 4. So blue wins. So here we're going to have 2 for the double bond, cyclopentene, and then the alcohol is on number 1, which we don't include because we know it's on number 1. So 2-cyclopentenol. Here's a few more practice examples. Again, pause the video and come back and check your answers. All right, this first one, the alcohol group ends up on number 2 either direction. So this is going to be 2-propanol. Next example, again, the alcohol group is in the middle. The methyl groups, everything's symmetric, so either direction you're going to get the same numbers. So we've got 2,4 dimethyl, 3, 5 carbons is pentanol. This next example, make sure you find your longest chain, which is going to be these carbons. If we started up here, the alcohols are on the far end. If we start down on the right, the alcohols are on the close. So that's where we're going to start. So I've got 1, 2, 3, 4, 5, 6, 7 carbons. I have the 2 alcohol groups, and I have 2 methyl groups. So we'll list the methyls first. We've got 3, 5 dimethyl, Then the alcohols are on 2, 4. 7 carbons is hept. And we put in the whole heptane because we need diol. Last example, we've got a double bond and an alcohol. We want to give the alcohol the lowest number, so we're going to start on the right. This double bond is on the end, so it is not cis or trans. We don't need to worry about including that. So we're going to have 5 carbons, so that's a pentene. We've got the double bond on 4, so 4 pentene. 2 is the location of the alcohol. So 4 pentene 2 all is the name for that structure.